Today's, like I said, today's webinar is from on single stage incubation. Henry Cole, one of our hatchery consultants, been with us 8 or 9 months, but prior to that, 30+ years experience in managing hatcheries and incubation and all different, seen a lot of different things in his years and some different hatcheries and different facilities. So he brings a wealth of knowledge to Jamesway and then also to this topic and the many hatcheries he's been in and worked in over the last year or so he's been with us. So with that, I will let Henry take over and make a presentation, and at the end I will be here again and we'll have a discussion, question, answer. So Henry, go right ahead.
Thank you, Dr. Bramwell. Let's get started here. Well, as Dr. Bramwell mentioned, this presentation today is on optimizing your single stage environment and also, troubleshooting your single stage environment. This presentation is going to be mainly focused on the maintenance side of things, what maintenance can do to help optimize your single stage environment. And, what I'm going to speak about today, I'm going to speak specifically about Jamesway, but the concepts are going to be very relative to any single stage operation, whether or not you're using single stage or any other manufacturer. It's going to be very relevant, though the presentation is more geared toward Jamesway. But keep in mind, if you don't have Jamesway equipment, this is still relevant information. So optimizing the single stage environment starts with 4 basic requirements. First being electricity. We need good, stable electricity coming into the hatchery. If we don't have the right voltage coming into our incubators or hatchers, you're going to have some issues. You can have fluctuations in your probe temperature, your humidity sensors, your temperature sensors, CO2 sensors. You can have issues with fans. There's a whole lot of issues that you can have if the electricity or power coming into your facility isn't correct. Water. We need clean water coming into your hatchery, not only on the chilled side of the equation, but also for the humidity side. If you have dirty water, high mineral contents, you're going to plug nozzles much quicker. You can plug up your cooling coils on your ECUs. It creates all kinds of issues if we don't have the proper water coming into the hatchery. Compressed air, also very important. We need the right pressure in our compressed air lines. It needs to be free of water, needs to be free of oil. If we have too much water in the lines, gets into your turning cylinders and will create issues. So again, we need good, clean, compressed air, free of water, free of oil. And then ventilation. I know Philip Perry spoke about ventilation a few weeks back. Ventilation is critical to the proper operation of our single stage machines or anybody's single stage machines. We need the right amount of air for that machine to operate, and we need correct operating room temperatures and pressures. So let's look at some electrical requirements here. So for incubators without dehumidifiers on a P60 cabinet, for example, we need a 20 amp circuit breaker. In this particular instance, it's a 230 volt machine. The connection or the operating load is going to be 9.6 amps, and the starting load will be around 17 amps. So if you're having issues with machines having sporadic screen problems, issues with machines not staying on calibration, take a look at your electric coming into your machines. And this would be for a water heated P60 cabinet. So what about a cabinet with electric heat. The requirements are going to be much higher, obviously, from the electrical side. So same P60 cabinet with electric heat, we're going to have a 50 amp breaker at this point, still the same voltage at 230, and the operating or connected load is going to be 37 amps now, and a starting load of 44 amps. So let's look at electrical requirements for our hatchers. A water heated hatcher on a P40 cabinet, we're going to need a 20 amp breaker. The voltage is going to be the same, 230 in this particular case. We do offer machines at different voltages, but in this particular instance, it's a 230 volt machine. Connected load is 9.6 amps, and the starting load, again, is 17 amps. For a P40 cabinet with electric heat, we now need a 40 amp breaker, same voltage of 230 volts. The connected load is 32 amps and a starting load of 38 amps. So what about the humidity requirements for our incubators and hatchers? So for an incubator that is a P20 through a P60, our requirement is 1.5 US gallons or 4.35 liters an hour. For a P80 or a P20 machine, we're going to need 2.3 US gallons an hour or 8.7 liters per hour. And then more importantly, the pressure. We need to be at least 60 PSI, so 60 to 100 PSI on our operating humidity water lines, or 415 to 690 kPa. Without the proper pressure, you're obviously not going to get the nice spray pattern that we desire, and we're going to end up having nozzles dripping out or not reaching the nice fine spray pattern that we desire. Also, if nozzles are plugged, you can have the correct pressure or the correct flow, but if nozzles are partially plugged with calcium buildup, you're also going to have some issues. But if you're running into issues with a machine not reaching the humidity levels that's required, and you see the machine constantly spraying, this is one thing to look at. So for a hatcher that we're adding humidity to, we want to, on our P20 to a P40 cabinet, we should be around 3 US gallons an hour or 11.36 liters per hour. The pressure is going to be the same. And again, the same thing about nozzles. If they're plugged or partially plugged, we're going to have some issues. Cooling system. If we have machines that are struggling to cool, the cooling icon is continually lit up. One of the things to check is your temperature at the ECU. Not necessarily what's going on at the chiller, and that is important, what the temperature is at the chiller, but it's more important what the temperature is at the ECU. And the temperature range at the ECU on our incubators should be 55 to 60 degrees Fahrenheit or 13 to 16 degrees Celsius. Optimum temperature is 58 Fahrenheit or 14 degrees Celsius. So let's look at what the requirements are for a P60 machine. A P60 machine needs, at the ECU, we're going to need, the range between 55 and 60 degrees Fahrenheit, and we need a flow of at least 4 US gallons a minute or 15.1 liters per minute. If we don't have the proper flow, we're not going to get the proper cooling. I've been to a number of hatcheries now where we have issues with proper flow going to our machines, and they're wondering why their machines are having issues, why they're having issues with chick quality, and why they're having issues with hatchability. Another important function of the cooling system is the operating pressure of that cooling system. Again, I've been to a lot of hatcheries, and the operating pressures are not correct. We need to have an operating pressure of around 30 to 40 psi, or 207 to 275 kPa. If you don't have that pressure, water, air always follows the path of least resistance. So if we don't have enough back pressure into the system, we're not going to get water going through the coils like they should. So flow is important and pressure is important on your cooling, and you'll see in a moment on the heating system. This was for incubators. So what about our hatchers? Again, our cooling system, same requirements for temperature as we had for our incubators. For example, on our P40 hatcher, we're looking for 4 gallons a minute of flow, or 15.1 liters per minute of flow. If we don't have the proper flow, we're going to have some issues. Again, the operating pressure, just like on the incubator side, needs to be 30 to 40 psi, or 207 to 275 kPa. Heating requirements. Let's look at the incubators first. Temperature at the ECU again, we're recommending 138 degrees to 145 degrees Fahrenheit, or 59 to 63 degrees Celsius, where the optimum would be 140 degrees Fahrenheit and 60 degrees Celsius. So again, with that same P60 incubator, we should have 4 US gallons per minute of flow, or 15.1 liters a minute of flow of heating water through the heating coils. If we don't have that, or if the temperature is too low, it's going to take much longer for your machines to get up to the desired temperature. Operating pressure is going to be exactly the same. We need 30 to 40 psi, or 207 to 275 kPa of operating pressure or back pressure on the system to get the proper flow through those coils. For our hatchers, same exact temperature setup as we did for our incubators. For the P40 hatcher, we're looking for 4 US gallons a minute, or 15.1 liters per minute of flow. And like I mentioned, the operating pressure is also going to be the same as with the incubators, that 30 psi, or 207 to 275 kPa. So if you're running into issues either on the heating side or cooling side, machines not behaving properly, one of the first things maintenance should look into is just checking your flows, checking your temperatures to make sure things are right. And if they're not, get those corrected and you should be back in the business. Compressed air requirements. As I mentioned earlier, we need good, clean air, free of water, free of oil. Operating pressure of our compressed air is 60 to 90 psi, or 414 to 620 kPa. If we don't have that operating pressure, if we're too low, you're not going to get proper turns or good turns, and you probably have turn alarms. Now, in some hatcheries that I've been into, we're running a higher operating pressure on compressed air because they have older racks, there's some binding going on, And, you know, I've seen some hatcheries that are running, you know, 100 to 110 PSI of operating pressure to make sure that the racks are turning. But our recommendation is 60 to 90. If you can't get your racks turned within that, you need to take a look at rack maintenance, which we will discuss here in a little bit. Ventilation, fuel for machines. Philip spoke about this a few weeks ago, and I'm just going to briefly go through this because I know he spent an entire seminar on this, but ventilation is very vital, and the proper ventilation is vital to the operation of these machines. We need the right temperature in the incubator or hatch or halls. We need the right humidity levels, and we need the right airflow or pressures within the incubator or hatcher hall and plenums. And if we don't have those things correct, we can again have some issues. So, you know, as part of a daily check for maintenance, they should be checking all their rooms, room temperatures, humidities, and pressures, along with plenum pressures, to make sure that we're operating within specs. All of our specifications for everything that I'm talking about today can be found in your Jamesway operation manual. And if you have any issues, you can always call Jamesway for further assistance. So let's look at our ventilation requirements for the incubator room. Minimum temperature on the dry bulb should be around 72 degrees Fahrenheit or 22 degrees Celsius. Maximum temperature 78 Fahrenheit or 26 degrees Celsius. And the optimum should be in between, which is going to be to 75 degrees Fahrenheit and 24 degrees Celsius. Now, depending on where your hatchery is located, you may need to make some adjustments to this, but this is a general guide that should cover most hatcheries. Relative humidity should be in the range of 40 to 50% RH. The optimum is around 45. So our incubator room, our room pressure of the incubator room itself with reference to the outside should be a 0.005 to a 0.015 inches of water column, or 1.2 to 3.7 pascals. And that was for P20 to P60 incubators. For P80 to P120 incubators, the room pressure is going to be a little bit higher. And also reference to the outside, we're looking for a 0.01 to a 0.02 inches of water column, or 2.5 to 5 pascals. So what about the incubator exhaust plenum? With reference to the incubator room. For a P60 cabinet, for example, we need to be at a negative 0.02 to a negative 0.03 inches of water column, or 5 to 0.75 pascals. And again, that's your exhaust plenum reference to the room. Same machine, and we're going to look at the exhaust plenum reference to the outside. And the reason I'm giving you both, because some folks, some hatcheries are referencing to the room and some reference to the outside. So with a P60 cabinet, exhaust plenum reference to the outside should be a negative 0.01 to a negative 0.02 inches of water column and a 2.5 to 5 pascals. If you're not within those operating parameters, you need to get your ventilation system to make sure that we are operating within those specifications. Too high, a negative pressure in your exhaust plenum is going to create a suction effect, and it's going to suck air out of your machines. If you don't have enough negative pressure, it's just going to lazily try to come out, and you're going to have the little bit of back pressure building up in your machine. Again, it's going to disrupt the airflow within the cabinet of that machine, and that's why these specifications are critical for proper operations of your incubators and hatchers. And again, it's not just Jamesway's incubators and hatchers, it's every manufacturer's equipment. So we'll take a look at the hatcher room. What are the conditions that are needed in a hatcher room? Minimum temperature of 72 degrees Fahrenheit or 22 degrees Celsius, with a maximum at 78 degrees Fahrenheit or 26 Celsius. Optimum will be 45 degrees Fahrenheit and 24 Celsius. Relative humidity, 40 to 50%, and optimum around 45. So if you have P20s or P30 cabinets for your hatchers, we're looking at a room pressure, the hatcher room pressure, reference to the outside should be a 0.005 to a 0.015 inches of water column, or 1.2 to 3.7 pascals. If you have a P40 cabinet, room pressure reference to the outside should be between 0.01, 0.02 inches of water column with 2.5 to 5 pascals. For your hatcher exhaust plenum, referenced to the room on a P30 cabinet, for example, we need a negative 0.02 to a negative 0.03 inches of water column, or 5 to 7.5 pascals. If we got the same P30 cabinet, our hatcher exhaust plenum, but now we're referencing it to the outside, what you need is a negative 0.01 to a negative 0.02 inches of water column, or 2.5 to 5 pascals. So we'll switch gears a little bit. And for folks that know me, this is one of my hot buttons, is calibration, because it is one of the most important procedures with our platinum machines or any incubation equipment, is calibration. Jamesway recommends that your temperature, humidity, and CO2 be checked after each incubation cycle. Hatchers, we suggest or we recommend once a month calibration checks. The reason this is so important is, first of all, the machine, whether it's an incubator or hatcher, has no idea that its calibration is off. It's going on the inputs that it has. It's trying to reach a certain set point, and if the calibration is off, like I said, it has no idea that it's off. So it is vital that calibration is done properly, and you take your time. You don't want to rush the calibration process. So you certainly want to be careful of who you put in to calibrate your equipment. You certainly don't want somebody that rushes through their work. You want someone that's very detailed, very methodical to do your calibrations. So what are some of the equipment that we're going to need? Jamesway sells most of this equipment, and I'm going to have, there'll be part numbers off to the right side of the these points, or these bullet points. So if you're needing any of this equipment, you can certainly ask your Jamesway sales rep to provide that for you. So for temperature, we're looking for a digital thermometer with probes. We sell this Cooper variety that is very accurate and works very well. I know Philip and myself carry these along when we do service calls to hatcheries to verify and check calibrations. We also provide a unit that does temperature and humidity. And a lot of folks have these blue boxes when I go into hatcheries. The nice thing about this particular unit, like I said, it does temperature, has a temperature probe, has a humidity probe, and it also has a strap probe, which is very handy. You know, a few moments ago, I talked about having the right temperature going into the ECU, whether it be on the cool side or the hot side. These strap probes you can easily strap onto your copper coils and get that temperature going right into the ECU. Makes it easy and very effective to get those temperatures. So we've got some more tools that should be at a hatchery. This is a digital manometer by Dwyer, and this is very good and handy to check your room pressures, your plenum pressures, pressures in your hallways, pressures in your egg room, chick room. Wherever you need to check pressures, this is a great tool, very easy, very effective tool, very accurate tool to use. Thermometer and anemometer. This is good to check flows coming out of your exhaust ports on your incubators or hatchers to see if you got the right CFMs going through the machines. Multimeters, which you can get pretty much at any hardware store, and a set of electrical screwdrivers. Again, you can pick those up at most hardware stores or catalogs, wherever, to get those. So let's look at, you know, some other specific tools that we have for our single stage machines. So from a Jamesway standpoint, a water flow tester. If you have a Jamesway single stage hatchery, you probably have one of these. Looks similar to this, where you have where the water is going to go in, and so typically there's an arrow here. So the water, this is your inlet, and this is your exhaust or your outlet. Water would then go in and through. Pair of shark bite disconnection tongs. This is helpful to disconnect your return water line from the ECU to then hook up to your water flow tester. CO2 meter, which is extremely handy for calibrating CO2. And then we have the CO2 calibration gas kit. Some of you folks have this as well. This kit is no longer available from Jamesway. So now if you're asking for a CO2 calibration kit, you will be getting this CO2 meter. I'll go through here in a little bit how to calibrate CO2 using gas and using the meter. It's also in our manual, but we're going to go through it in this presentation. So, proper temperature calibration for our Platinum machines. First, the machine needs to be at the program temperature, which typically we recommend, you know, around 24 hours to 36 hours after the eggs are set. The machine's up to temperature, and we want to do the temperature calibration at this point. It's at the most stable point. We're not adding humidity, we're not adding a whole lot of heat, and we're certainly not adding any cooling at this point. If you're doing hatchers, we recommend around 2 hours after transfer. Again, that's when the machine should be at its most stable point. If it's not, you just need to wait until the machine is stable to do the calibration process. You don't want a whole lot of heating, cooling, or water spray going on when you're calibrating either incubators or hatchers. And then ensure that your humidity spray is not on during the calibration process, because that will certainly affect your readings. You then want to use a known calibrated electrotherm or thermometer, probe, whatever. It needs to be a known calibrated unit. You're then going to go up onto the top of the machine, and this, for the temperature, it's very handy to have a second person, one person to get on top of the machine and the other person down by the console. So the person's going to get up on top of the machine. There will be a grommet and a hole next to your temperature probe. You will insert your probe that you're going to do the calibrating with into that hole next to the temperature probe, because obviously we want our calibration thermometer as close to our temperature probe that's in the machine as possible. We're going to wait until that temperature probe or electrotherm stabilizes. Typically, you know, it's 3 to 5 minutes. Once it is stabilized and it's no longer fluctuating, then you're just going to record that reading. You're going to go to the display. You're going to go into the display menu, and you're going to enter here on calibrate. When you get into the display menu, you're going to hit calibrate, and then you will, a screen will pop up. You will enter the actual reading off the electrotherm. And then when you do that, you will then get an offset. So what the difference in that temperature was, and that process has then been completed. But again, this is not a job that you need to rush, and you certainly don't want to rush doing, because if you calibrate improperly, that's worse than not calibrating at all. So you definitely need to be selective on who machine, again, running in a stable state. We want to make sure that you're you go into the left side of the door and you place that humidity probe over the machine's humidity probe, shut the door, and wait until that humidity probe or electrotherm stabilizes, typically around 5 minutes or so. Once you have a stable electrotherm, go into the setup screen, go to the humidity calibration, just like we did for temperature. Press the calibrate button. Another screen will pop up. You will enter the actual humidity from your calibration thermometer, and you will then see an offset at this point, and you're good to go. You can also calibrate the machines when they're empty. Some folks do this. So when the machine is empty, you can open the doors and allow that machine to stabilize to the room conditions, and then calibrate the humidity at that point to the room conditions. And that would be equally acceptable to do. And so there's two different methods to do that. So for your CO2 calibrations, we're going to go through calibrations with gas. So before we start the calibration process, we're going to go to the setup menu. We're going to press the N2 icon and then press the reset button. We're then going to go to the CO2 span icon, this one, and do the same thing, and press the reset button. Depending on the CO2 sensors you have, you're going to remove the lower filter on the CO2 sensor. You're going to then screw on the fitting that's attached to the regulator and hose into the CO2 sensor. And for zero calibration, to zero out the calibration, we're going to use nitrogen gas. To calibrate then for CO2, we're going to use a 0.5% CO2 gas, or 5,000 ppm concentration of CO2 gas. So let's look at each one specifically. to do the zero calibration, we're going to attach the nitrogen tank to the regulator, and then we're going to attach the hose to our CO2 probe, CO2 sensor. We're going to turn on the gas and ensure that the gas is flowing. On that flow meter, you're going to see that there's a little ball that will float up and down, and we want to make sure that we've got nitrogen flowing to that meter or to that sensor. You're going to allow the flow of nitrogen to that sensor for about 3 minutes. After 3 minutes, you're going to go to the setup screen. You're going to push the icon of NCalb 0. So this is going to be, you're going to calibrate to 0. You press the 0 gas button, which is this one. You're then going to exit the setup screen, and you're going to look at your CO2 display, and it should read 100 parts per million. If it doesn't, repeat steps 1 through 5 again. Once you've got a CO2 reading of 100 parts per million, you're going to detach the nitrogen bottle from the apparatus, and then we're going to calibrate the CO2 gas. So again, we're going to do the same exact thing. We're going to attach the CO2 at the 5,000 ppm bottle to our regulator and hose assembly. We're going to go to the setup screen, and we're going to push the CO2 calibration span button. We're going to turn on the gas and ensure gas is flowing. We're going to press the span gas button, this one down here. We're going to let the gas flow for about 3 minutes to that sensor. After 3 minutes, we're going to go back to this same screen. We're going to push this CO2 span gas button again. We're going to exit the setup, and then we're going to go back to our CO2 display screen, and we should have 5,000 ppm. If we don't, again, repeat these processes. Once you've calibrated the CO2 to 5,000, you can detach the CO2 bottle from your calibration kit, and you're good to go. You've now calibrated your incubator or hatcher for CO2. If you don't have a gas kit and you have a meter, let's take a look at calibrating CO2 with a meter. So for the 0 calibration, we're going to insert the instrument into an empty machine so we can do the 0 calibration with no eggs in it. Let the reading stabilize for about 5 minutes. After 5 minutes, you're going to go to your setup screen, and you're going to push the icon labeled nitrogen calb 0, just like we did if we were using gas. This is what's going to show up. You're then going to press the instrument. You'll press this. You'll then get a screen. You will actually put in your actual reading that you attained from your calibration instrument. Press OK, and you've just zeroed out your calibration for CO2 on that machine. To do the span concentration, we're going to have to wait until that cabinet has at least 4,000 ppm of CO2. With our Jamesway Platinum machines, typically we build 1,000 ppm of CO2 on a daily basis. So it's going to take roughly 4 days to get up to 4,000 ppm. So typically what I recommend to folks is wait to day 5. You should be somewhere between 4,000 and 5,000 ppm on CO2. That'd be a perfect time to calibrate the CO2 on the span side. You're going to put your probe into the machine. You're going to go to the setup screen, and you're going to push the CO2 calibration span button, this one here. you're going to end up with this screen here. You're then going to press the instrument button and then enter the value that's on your CO2 calibration reader. Press OK, and you've now calibrated your machine for CO2. It's quite easy. I spoke a little bit about, a little earlier about flow testing. I showed you the instrument that we need. To test flow, this should be done on a regular basis, at least every 6 months, or if you have any issues. But at least on a 6-month basis or twice a year, maintenance should be checking your flow on your incubators and hatchers. So on the ECU, we're going to disconnect the hot or cold line from the shark bite fitting on the return side. We're going to connect the hose to the tester on the supply side. And I'll have a picture of this on the next slide. Again, follow the arrow that's on the meter to show direction of flow. And this is coming off of the ECU coil pack. You're going to connect the other end of the tester, so the exit end, to your return line. And then you're going to disconnect the fan connector from the ECU. Don't need the fans running at this point. And this is going to be on an empty machine. You're going to go to the front panel of the machine, and you're going to change the temperature set point to either above or below the reading, depending on if you want hot water to come on or cold water to come on. Then turn your fans on, and after the solenoid opens up, you can then verify flow, and in this particular case, 4 gallons a minute, or whatever your manual says for the machine that you have. And then if we did hot water, you're going to do the cold water and repeat the process. So this is the ECU here, this red loop. Here's your machine control panel. You've got your, your solenoid, which is still going to stay connected to the ECU. We're going to disconnect from the return side the hose that goes to the ECU. So we're going to hook up this flow tester, and you can see the water flow arrow here. We're going to hook this end up to the ECU end, and then this end is going to get hooked up to your return inlet. And then, as I mentioned, go through the process, adjust the temperature, and once the solenoid, this solenoid is activated either on the hot side or the cold side, this will start floating up and will give you a flow. Okay, at times we need to do a damper calibration. So when you're checking your machines after every transfer or after every hatch, you obviously want to make sure that your dampers are in sync. So your inlet dampers and your exhaust dampers are synced with one another. If you have issues and you're seeing that these are not synced with one another, or they're not synced with what the display is saying. So for example, if your display says the dampers are about 50% open, and when you look and you see that they're only maybe 10 or 20% open, we're going to need to do some investigating and do a damper calibration. This is extremely easy to do. Again, you can follow the steps. These are also outlined in your operations manual. First thing we're going to do is we're going to loosen all of the nuts. There's U-clamps on the damper motor from the damper rod. You're going to loosen those nuts up on the damper assembly for all your dampers. So your inlet and your exhaust dampers. You're going to go to the setup screen, and you're going to push the damper, or you're going to push the icon labeled damper calibration. When you do that, this screen's going to pop up, and it's going to tell you to make sure that you loosen the intake and exhaust damper motor nuts. You're going to then say proceed. So you're going to hit the yes button and proceed. Press OK. The damper calibration will start. So what's going to happen is that motor is going to start turning if you take a look at it, and it's going to go from 0 all the way to open and go back down to fully closed. Got to wait until the damper calibration process is complete. And then once it's complete, you're going to get another screen, and it's going to tell you to make sure that the dampers are, you manually put the dampers in the fully closed position, because your nuts, these nuts are loose. You're going to go into the fully closed position. You will then tighten those nuts back up onto the damper assembly, and then you're going, fan current calibration. Typically, this is first done when the machine is set up. So when the installer comes and installs your machines, when he turns the machines on, he's going to typically do a fan current calibration on the machines that have this feature. Some of the older Platinums, like Platinum 1s, P1s, don't have this, but the P2s, especially the newer ones, will have this fan current calibration ability. So if the installer doesn't do it, then whoever's doing the commissioning will typically take care of this. So typically you're just going to need to do this once. However, if you're changing out motors, or if you're getting false alarms on you're getting false fan failures on your machines, you may want to go through and do a fan current calibration, and we'll go through that process. So you're going to turn your fans on, and then in the main screen, you're going to go to alarm setup. Go to the alarm setup function. You're going to choose the fan current calibration function, and then hit OK to commence the fan current calibration. This function is not going to be available again on all machines, and it won't be if the fans are off. So the fans have to be on for this function to happen. If this button is not visible, then either you don't have fan current sensing available, or you have a software version that doesn't have it. And typically a good way to tell is if you've got a machine and on your ECUs, if you have them sail switches on each of your fan motors, you don't have this ability. But if you don't have those sail switches on your ECU fans, then you should be able to have this current calibration or fan current calibration available. So what's going to happen is the machine's going to perform a calibration by stepping up and stepping down the fan speed. So it's calibrating the current at each of those steps through the process. This is replacing that fan failure sail switch. This is a very accurate system. Now, if your machine has fails, what you're going to need to do is go and check your SMA 111 board, which is in your main console. That's your main computer board for the operation of your incubator or hatcher. Look at position J6 and check the jumper pins to make sure that they're between 1 and 2 and not 3 and 4. And again, if you have any questions, you can certainly get a hold of somebody from Jamesway. So let's switch gears a little bit here. So prior to setting eggs, we need to make sure we're checking each incubator rack for ease of turning. Talked a little bit about this, making sure that we have the proper flow and the proper pressure of compressed air, free of water, free of oil. And the best way to do this is check empty racks before you put eggs on them to make sure that they easily turn between 25 and 30 PSI. If not, please check into why the rack's not turning. And this should be done as a matter of regular routine, because I've been to hatcheries before, they're having turning issues, and the reason they're having turning issues is because it's a rack issue. Hoses are pinched, hoses are leaking, the turn actuators are leaking. There's usually a reason for it, or the rack is out of square because of mishandling. A lot of times they're being transported or moved around with pallet jacks, and sometimes that will alter the squareness of these racks. And if we've got any binding going on, that's gonna help bind up, and you're not gonna get a good turn like you should, especially when it's heavy and loaded down with eggs. So a quick way to do it, and like I said, this should be done as a matter of routine. Nothing's worse than having to go back into an incubator after you've set it and move eggs off of a rack onto another rack. You should just make sure that the eggs that are going into an incubator, when you set them, these racks are in good shape. So prior to loading eggs into an incubator, maintenance needs to go through and check for any air leakage. Check the doors, check gaskets, make sure door latches are working properly. Want to check your humidity spray. Make sure that they're spraying like they should. We don't have any clogged nozzles, or the orifices haven't opened up, and our spray droplet size is too large. We want to check for any water leaks, especially from the connections onto the ECU, making sure everything's good there. If you're adding anything that you're doing to add for fogging, want to make sure there's no water leaks or leaking any chemicals there. Want to make sure you're checking your dampers, making sure that they're closing and opening properly, not only the inlet, but on the exhaust side, like I spoke about earlier. You want to listen for any compressed air leaks on your line connections. You want to be sure that your probe protective covers are removed. So we have probe protective covers for our CO2 and humidity sensors. A lot of times when sanitation gets out of these machines, they forget to take those covers off. Certainly want to make sure those covers are off so that we're getting good readings for CO2 and humidity. You want to do a visual check for cleanliness of the machine as well as the probes. You want to check that your fans and the motor or sail switches are working properly, that the fan motors are going in the correct direction, and that they're all blowing up on the ECU. So starting with an empty incubator, it's important not to have the incubator pre-cooled. We'd like to leave the incubator off and the doors closed till about 2 hours before loading the eggs from the egg room into the incubator. Around 2 hours before loading the eggs into the incubator, you're going to go open up the incubator doors with the fans off, dampers closed, and allow that room to gradually get to the actual room temperature of that incubator room. So the final setup for setting is, once the eggs are in, we're going to shut the doors, turn the fans on. We're going to start our profile. Anytime you enter a date that's in the future, you will be asked how long you want to hold these eggs, or how you want to hold these eggs until that profile starts. Typically, our holding or setting profile will be somewhere around 75 degrees Fahrenheit, 65 on relative humidity, and the damper will be closed. we typically suggest a minimum of 8 hours of holding time, which is needed to stabilize the egg temperature and get a nice uniform egg temperature throughout that egg pack in that incubator. Now, there are some incubators that, for whatever reason, their egg coolers aren't big enough and they need to hold eggs for a longer period of time. This can be done. Hatcheries can hold eggs for over 96 hours if you need to. What we recommend is have a temperature of 68 degrees Fahrenheit or 20 degrees Celsius, which is about the coolest that our incubators are going to be able to maintain with a 58-degree chilled water temperature. Typically, hatcheries, their egg rooms are going to be somewhere around 65 to 68 degrees Fahrenheit or 18 to 20 degrees Celsius, and that's pretty common. So again, we recommend 68 degrees Fahrenheit, 20 degrees Celsius with a humidity of 70% for the standby mode and with a fan speed of 40% in the holding mode. If you start seeing water accumulating and collecting on the floor, you can open up your damper anywhere from 1 to 5% to let a little bit of that moisture out. And the cabinet can usually maintain the egg room set point, but it has difficulty if you're getting fresh eggs, putting them in a machine and trying to cool it down to that point. The machine's going to have a hard time cooling the egg mass down. But if it's at the if the eggs are already at the egg room set point, our cabinet will be able to maintain that. And then eggs, typically when you're moving eggs from your egg storage room to your incubator, you need to do that quickly to minimize any condensation issues that might arise. So again, when we set normal recovery time from when we start a profile is typically 4 to 5 hours from what I've observed. Again, there might be some variation based on temperature of your hot water, if you've got, or if you're using electric heat, or what size machines you have, and what the temperature of your egg mass is. Might fluctuate a little bit, but typically your machine should be able to get up to temperature within 4 to 5 hours after start of the profile. And again, most profiles, at least on the chicken side, is going to be around 100.3 to 100.4, again, depending on your specific profile. If you're not able to achieve your desired specific starting temperature within your normal time, you need to start looking at your hot water loop, like we spoke about earlier. Check your temperatures, check your flows, look for air leakage. Are your dampers closed? Are your door seals messed up? Take a look at those types of things. I've shown you and told you what to look for. Now you can start applying some of those into a given situation if you don't get up to a certain temperature. Also, very important when we're setting single stage machines for our success and your success, if there's no operational problem, do not open the doors until transfer. If there's no reason to go into these machines, don't go into the machine. Another reminder for setting sometimes gets overlooked is when you're setting multiple single stage incubators on a given day, it is important to stagger your set timings based on how long it's going to take to process chicks from one machine. For example, if it takes 2 hours to process chicks from a given machine, you want to stagger your set timings by 2 hours for every machine in that set. Otherwise, if they're all set at the same time, you're going to have chicks sitting in hatchers 6, 8, 10 hours longer than they need to. And then you're going to run into issues with dehydration and livability issues out on the farm. Prior to loading eggs in a hatcher, again, maintenance needs to go and check for any air leaks, check doors, gaskets, check your humidity sprays, check for any water leaks around the ECUs or anywhere else. Again, want to check our dampers to make sure that they're opening and closing properly. We want to make sure that our probe protectors are removed. Check for visual cleanliness of the machine and our probes. And again, we need to check our fans and our fan sail switches to make sure that they are positioned properly and that the fans are rotating properly and are blowing in an upward direction. So when an incubator is emptied at transfer, ideally we want to take that machine off a profile. We want to set the temperature to 85 degrees Fahrenheit, set the humidity to 50%, set the damper to 0, turn the fans off, and keep the doors closed. Wait until sanitation comes in and gets the machines closed. A lot of times I go to hatcheries and they've got all these machines that are not running, that have no eggs in it, that have just been transferred out. Sanitation hasn't been into them yet, and yet they're still on profile and they're, you know, still heating or cooling. And it's just a waste of resources, folks. There's no sense in having those running when you don't need to. So for an empty hatcher, once all the chicks are removed, again, we want to do the exact same thing. We want to take the hatcher off a profile, set the temperature to 85 degrees, humidity to 850, damper to 0, shut and latch the hatcher doors, turn the fans off if they're not already off. And what we want to do, and the reason we want to do this, is if this procedure is not properly done, the remaining hatchers within that common room or common plenum will have their airflow disrupted. Because again, air and water will follow the path of least resistance. So if you're emptying out hatchers and the machines are still running and the dampers are wide open, the air going into the exhaust plenum is going to get short-circuited and going through those empty machines, and the poor chicks that are left in the hatchers that haven't been pulled yet are going to be starved of some needed air. So it's important that you do this. Again, I've seen this a time or two and the results aren't good. So we talked a lot about maintenance, and we're going to continue to talk about maintenance for the rest of this presentation. Maintenance is key to optimizing your single stage environment, whether it's our Jamesway machines or anybody else's machines. It is important and vital that you have a good maintenance program. So there's typically two types of hatchery maintenance. We have a reactive maintenance, which is a maintenance program that is fixing things that break. When things break, we get it fixed, or they're just putting out fires all day long. And that's what they do, is they run around the hatchery, putting out fires, fixing things that are broken. We want to get away from that type of maintenance and get into a preventative maintenance program and be more proactive for a number of reasons. One, the equipment's going to last longer. It's going to work more optimally. You're going to have less downtime as far as the equipment. You're going to have better chicks per man hour because the equipment's not going to be broken down during the process day and you've got folks standing around. So machines are going to last longer, parts are going to last longer. It's just a much better way of running a hatchery with a preventative maintenance program versus a reactive program. So in our operations manual, we have a section with a recommended maintenance schedule for our incubators. Whether they're single stage or multi-stage, we have a preventative maintenance schedule guide. So what we're going to do is we're going to kind of go through this and break it down, what needs to be done daily, weekly, and so on. So from a daily preventative maintenance setup, we want to check the machines, check the machine operation. So we want to make sure that the machines on a daily basis are running at the set point that the profile is wanting them to. We want to make sure the day in profile is correct. Like I said, the machines are meeting the set point. Our damper openings, our CO2, humidification, heating and cooling are all working typical for that stage of incubation. Or another way to say it is, if you've got 4 incubators that you're setting today, all 4 incubators should be running very similar to one another. If one is way off, either too warm, too cold, that should be a red flag that, hey, we have an issue. Same with your hatchers. If you've got 12 hatchers that you're transferring into on a given day, those hatchers should be running very similar to one another. If they're not, we need to take a look and see what's going on. And then also watch for irregular conditions, or if you smell something that's not normal, or if you hear something that's not normal, you need to take action. A lot of times people will make note of it, but don't do anything about it. So it's important, if you notice something, and it's more important that if maintenance notices something, that they take action. Check your ventilation operations. Are your set points correct? Like I mentioned earlier, your rooms, your exhaust plenums, are we maintaining our proper set points? Are we operating within the normal range of what it should be? I know there's times, been to hatcheries, it's extremely windy and the pressures are all over the place. Those are some things that you need to take a look at, and that should be done on a daily basis by somebody, and preferably maintenance. Check your compressed air system. Is the pressure correct? Are we in the correct operating range? We have no excessive water built up in those automatic spin down filters. We want to check our chiller and our boiler if you have one, to make sure that 1, they're working, and 2, that we're working within the proper operating temperatures or specifications that's required. From a weekly standpoint, we need to inspect our compressed air system. We want to look for leaks, verify again pressure is accurate, and drain our main accumulation tanks. Those tanks will start filling up with water, and on a weekly basis, that water needs to be evacuated. Changing our HVAC filters, not only in the hatchery, in those rooms, but also up on the roof on the HVAC units. So you should have a routine schedule for your egg room, your incubator room, hatcher rooms, chick rooms, washrooms, clean rooms, etc. They should have a routine maintenance or routine schedule as to when those filters are going to get changed out. A word of caution is up on the HVAC units. There's filters inside those units, but there's also usually a mesh filter on the incoming air side into those units. A lot of times those get forgotten. And depending on where your hatchery is located, those can get plugged up fairly quickly. So if you're having issues with pressures and everything seems to be looking okay, go up on the roof and check your inlet air filters to the to your rooftop units. They may be plugged, or the filters within those units may be plugged as well. So what about preventative maintenance after transfer and wash. Our door gaskets and sweeps need to be checked. Check if they're torn, missing, and if they are, they should be replaced. The ECU fans, we need to check for excessive vibration. An easy way to do that is when you're looking at your ECU fans and you're looking at the motors, if you can't read the nameplate because it's vibrating so much, we've got an issue to take a look at. Check all your fans that they're going and moving in the correct rotation. And again, that they're blowing upwards. Need to make sure that the turn off and repair motor, we need to turn off and repair motors that are running backwards. For example, if you've got P1 machines and you have a weak capacitor, you can have motors running backwards. Want to verify if you got any air leaks or any leaks coming out of your ECU on the coils. So on the hot and cold side. Check your humidity nozzles for any buildup, scale, they're dripping, if we got any leaks. Again, check your dampers and exhaust fans, verify that they're working properly. Also want to check the touch screen on your incubator and hatcher and verify the following buttons are working, like the ECU fan buttons, the turn buttons, the alarm bypass, alarm silence buttons. Want to make sure that your touch screen is working the way it's supposed to. Also on the console, we want to check, again, after every time we transfer or we go into the machine, we want to verify that that e-stop is working from a safety standpoint. We want to check that power and alarm lights are working like they're supposed to. Our racks, our dollies need to check and grease wheels, caster plates. Need to check turning. I mentioned earlier, and I'm mentioning again, empty machines, we should be able to turn at 25 to 30 PSI or 172 to 207 kPa without any eggs on them. If you have an issue and they're not turning at that pressure, you know, check any issues that are rubbing or binding or repair any air leaks. Sensor maintenance. This is often forgotten. You want to check your sensors, make sure that they're clean. Want to check calibration. We went through that at length. And calibrate if the difference is greater than, on the temperature side, if the difference is greater than 0.3 degrees Fahrenheit, we want to recalibrate. On the humidity side, for the humidity sensor, again, check that that filter is clean and it's not wet. If it is, you need to replace it. Check calibration and recalibrate if the difference is greater than 2%. CO2 sensor. You need to check and clean that filter on the CO2 sensor. We're going to check calibration, and if you're greater than 500 ppm off, you need to recalibrate. So what about PMs on a 3-month basis? We want to take a look at our consoles, the control console, open them out, vacuum out any dust that may have accumulated. Typically, you're not going to see a whole lot on an incubator side, but on the hatcher side, you certainly can have some dust buildup in there. Verify that all your wires are in good condition and are properly seated. Want to check our damper and exhaust fans. Test the dampers to ensure that they're moving like they're supposed to. Run damper calibration like I had spoke about if we need to. Verify that the dampers all close fully to 100%. And then not only that they close fully to 100%, but on the display that they're saying that they're closed to 100%. And I always like checking that they fully open to 100% as well. So I always check both fully closed and to the 100%. And then check that the dampers are free from interference that will cause them to bind or hit something so that they're not going to open up completely. Cabinets, want to check your silicone joints. And if you've got silicone that's starting to come out, certainly want to get that replaced. Again, check your door sweeps and replace any door sweeps or gaskets, and also gaskets around your inlet dampers, and replace those if necessary. Sensors, verify that all your sensors are in good working order. Twice a year maintenance. Doors, check your door seals and that the latches are latching properly. Another good thing is go inside the incubator or hatcher and close the door with the lights off to see if you can see any light coming in from the hallway. If you do, it's an area that needs to be corrected. Your hatchery support system, so routine inspection of your HVAC equipment. Getting ready for your season changes, again, depending on where your hatchery is located. You know, verify your hot and chilled water supply is at the correct temperature, pressure, and flow. And the flow meaning we would go through and we would check our flow for heating and cooling side in our incubators and hatchers. Verify humidification is at the proper pressure and volume that's recommended. Here's a picture of an ECU, and you can see fans 2 and 3, one's in the middle, are going to rotate in a clockwise fashion. 1 and 4 will rotate in a counterclockwise fashion. Another thing to note is that there are differences in blades. The ones that are rotating in a clockwise fashion, the one with the red arrows, will have a blade of a PB 142. The ones that rotate in a counterclockwise fashion with the blue arrows are a fan blade of a PB 143. When you're ordering fans, replacement fan blades, need to make sure that you put the right fan blade on the right fan to get the proper airflow and distribution through that cabinet. Another important part of maintenance is troubleshooting. Troubleshooting any issues that may arise. In our Jamesway operations manual, we have an extensive troubleshooting chart. This is a chart that is very well laid out. It'll ask you questions and you follow it from top to bottom, following yes, either yes or no, and work your way down through the process until you get the problem fixed. When I go to hatcheries, and I know when Philip goes to hatcheries, we use this same exact troubleshooting chart that you guys have in your operations manual. And that's what we use, is we'll go through and we'll start from the top and work through the process until we find out the solution. This saves time, saves money. Instead of spending half a day working on a machine, swapping out 20 different parts that you don't know whether they're good or not until we get the problem fixed, versus spending 10, 15 minutes, half hour going through the troubleshooting guide, swapping out the one part that needs to be changed out, will save you just a ton of time. And from what I've found going to hatcheries, a lot of the hatchery maintenance personnel don't even go and take a look at this, don't even open up the manual for this. I'm encouraging y'all to let you know, one, that it's available, and one, this is a great resource to help troubleshoot any hatchery issues that you might have with your equipment. So regardless of any size hatchery that you might have, no matter how old that hatchery is or where it's located, that hatchery is only going to be as good as the routine and preventative maintenance program that it has. So with that, Dr. Bramwell and I will entertain any questions.
Thank you very much, Henry. Hopefully we can see your face again as soon as you turn your camera off a little while ago. But very good information. We have a few questions coming in that we'll address here.
Oh, sorry, I didn't know my camera was off.
Well, that's okay. That's okay. Your presentation was there, and that's really the most important thing there. So I've got a few questions here. Let's address in the time that we have left. A couple of things. What would cause, there's some troubleshooting issues maybe, what would cause some excessive condensation on the ECU coils in our machines? We've had several people ask about that. What are some probable factors of that?
If your operating temperature is too cool, you can certainly run into excessive condensation building up on your coils. So again, that's why I mentioned this. We need to be within the operating parameters. If you are within the operating parameters, there's got to be a reason that those machines are calling for that much cooling. So we either have the temperature out of spec, or our flow, we don't have the proper flow. Our flow is less, so it's having to run cool much longer than it should. So again, I would go through, check your temperatures and check your flows to make sure that they're within the Jamesway specs.
Okay, thank you. Very good. As far as your calibration stuff, you've discussed that, and it's an incredibly important point. A couple questions here, and how often the CO2 sensors need to be calibrated, and also when we calibrate them, should they also be calibrated on the high level as well?
So again, Jamesway recommends for incubators, we calibrate temperature, humidity, CO2 after, prior to every set, or after every, for every set. Hatchers you want to do on a monthly basis. So when you set eggs into your incubator, 24 hours after set, you're going to check your humidity, you're going to check your temperature, and then CO2 you can do prior to setting eggs in for the 0 side, and then 5 days later you would then check your high side.
Okay. What if we have a customer has different machines in the same corridor? We've had this question in other topics. How do we deal with that with the different needs?
Well, if you've got different machines, different sized machines within the same corridor, you definitely want to set your specs to meet the requirements for that larger machine.
Yep. So take care of the one with the most demands.
Yep.
Do the single stage machines, question here, do they have like a power surge protector to prevent power loss or surge, protecting the parts?
No, you should have that coming into your hatchery prior to going from when your incoming line or the power coming into the hatchery. There should be a surge protector there prior to going into your breaker box, because if not, if you have a surge, it could then migrate anywhere within the hatchery. So no, we don't have a surge protector on the machines.
Not at each machine, it should be.
Right. Now you could certainly put them on, but typically no, we don't have that as a standard on each machine.
Okay. Here's an interesting question. So as recommended, if we check the calibration every month, then that means that we're essentially checking the calibration machines at different embryonic stages of different demands of the machine. Is that going to be an issue?
No. Hatchers you're going to do on a monthly basis, and you're going to do 2 hours after you transfer into them. So you're not just going to pick a month or pick a day in a month and do all your machines. So for hatchers, 2 hours after you transfer, once a month. For incubators, every time you set into them.
Okay, so that's the difference. The hatchers are once a month, 2 hours, and the incubators every time we set.
Right. So basically, yeah, hatchers 2 hours after you transfer, once a month, which was in my presentation, maybe it wasn't clear, and then incubators after every time you set into them.
Okay. Yeah, some of these I think are just clarifying things. Maybe they misunderstood.
Yep. No, that's fine.
Yep. So here's a just a kind of question that says if the hatcher pressure need is higher than the setters, could that potentially create a biosecurity issue if you've essentially got pushing air from the dirty to the clean side? If your hatcher pressures are higher than setter pressures, I mean, they're not in the same hallway, but is that an issue to consider?
Well, typically there's usually, you know, a hallway or two in between the incubator hall and the setter hall. And yes, you want to, obviously the air needs to go more negative as you go towards hatching and towards processing. So you need that proper flow. And if you don't, you'll need to make some adjustments. That's why we have ranges within our, you know, incubator hallways and hatcher hallways. There we do have ranges there. So as long as you're fitting within that spec, you just want to keep in mind the proper airflow.
So as a collective group in the hatchery, we have a flow, but then when each specific unit, we have demands.
Yeah. Now each incubator will have its own set of demands, but that's going to be based off of your room pressure and your plenum pressure and how far that damper is open or closed.
Should not affect the hatcheries.
Right.
Okay, we've got a few questions here, then some we'll have to answer in writing afterwards. Henry can respond to a couple of these others. But one final question I think is really is a very good question at the end of your presentation here. So you talked about single stage, one of the product lines we have other product lines as well. What do you see in your experience the best advantage of using single stage incubation over multi-stage?
Well, that's pretty easy. There's a few different there's a few different
Sum it all up
advantages
right here. Everything we just talked about.
There's a few different advantages. First, you know, from a hygiene standpoint, you know, everybody's going antibiotic free, or, you know, a lot of folks are going antibiotic free, and running a multi-stage hatchery, very difficult to get to that point without some sort of interventions. Whereas on a single stage hatchery, you can clean, they're all in, all out. You can clean your incubators after every transfer. So that's one aspect. From a time and labor standpoint, it's much easier setting eggs. You can put the eggs in, especially if you've got, you know, a Sunday set or Monday set. You can set those eggs on a Friday afternoon if they're in your hatchery. You can get everything set and put in a program, put in your delay, your holding pattern, and, you know, those machines will start profiling when you want them to do so. Next is for a multi-stage machine, we have to remember that we are incubating for the average. So you're going to see much better hatchability, chick quality when things are right in a single stage machine, because you can tailor that profile to the specific needs of that developing embryo. So again, I mean, I can go on and on and on, but you know, those are just a few quick points as to what the advantages are on a single stage versus a multi-stage.
Right. Okay. Yeah, thank you very much. I'm kind of running out of time here, but the other questions we have there will be answered directly to you. Thank you all for participating with the webinar Wednesday today. A lot of good information here, very thorough, as always, from Henry. Next week, we'll have, at the same time, we'll have one on webinar on the HatchCom 4, the new HatchCom 4, and the advantages that it can give you in hatchery, monitoring your hatchery. So hopefully you'll come to that, and if you don't have HatchCom 4, you might want to see what benefits it has and potential use for you in your operation. So thank you again, and look forward to seeing you next week. Bye.
Bye.